So, welcome back. This is our lecture 6, and in this lecture, we are going to start a new chapter, which is propositional logic. So, for moving forward, uh, we should get to know that what is propositional logic. So, as there written a definition in front of you, that propositional logic is a procedure to provide reasoning through statements. Do you know what is reasoning and what are statements? Okay, so I think you all know what is reasoning. If you don't know reasoning, please check out that in Google. But for your information, let me tell you what is reasoning. That when you have to conclude something, okay, when you have to conclude something, then it is known as reasoning, which means that you have given some one or two test cases, just like you have given shape like this, then shape like this, then shape like this. Okay, all right. So you have to conclude that what can be the next shape it may form. Okay, so this is known as reasoning. All right, and what are statements? Statements are just simple sentences. Okay, what we use in our daily life. So, what is propositional logic? Procedure to provide reasoning means we have to conclude a result with the help of statements. So, in that context, let us move forward. All right. So, there are propositions and there are propositional variables. So, what are propositional variables? Okay, we use propositional variables to represent the propositional statements. All right. So, okay. So now, what are the propositional logics and variables? We are going to understand them. Okay. But before that, as I told you, that we have given some previous statements, and from there we have to conclude that what can be the result. Okay. What or what we have been asked. So there is a definition known as truth value. Okay, what is truth value? Truth value. So truth, what is truth value? It is the outcome. All right, outcome of proposition, whether it is true or whether it is false. Okay, so have you got? It is the outcome of the proposition. Okay, so we form truth tables. All right, when we represent the outcomes in a table form, in a tabular form, then it will be known, and with the help of truth values. All right, then we will be getting the truth table. Okay, I will tell you how to make the truth table, but before that, you should remember that how to form a proposition. All right, how to form a statement. So before moving towards that, we have some. So let me tell about variables first. All right. So variables are simple names where we represent the data. So it can be either B, either C, or A, capital B, capital C, dash, 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 and dash, until what? It can be Z also, and capital Z. All right. So now there are some operators also. All right, operators, you mean what? Operators are used to operate. All right, they shows the relationship between them, the variables. All right, so operators. So in propositional logic, there are some operators. So what are they? They are just like you can say plus, sorry, can be plus, can be dot. All right, I will tell you the meaning of these two. So just remember, there are plus then dot. Then this plus and this dot can also be represented as, this plus will be represented as this v. All right, and this dot can be represented as this flipped v. All right, upside down flipped v. Okay, then we have this symbol also, this variable, and this. I will tell you the meaning. All right, don't worry. Just remember that they are there. Okay, and we also have some others also that we will be discussing. It is necessary. Okay, so now, so when we then have you understood the truth table, truth values, and these variables? So we, and just like in the arithmetic, we have addition, subtraction, multiplication, and division. All right, they have their meanings. All right, so they are operators and they operate on something. So in the similar way, in the propositional logic, the propositional logic, we also have some connectives. That is, we also have some the set of rules or the set of operators. Okay, so first we have conjunction. All right, conjunction. So conjunction is represented by what? It is represented by this dot or this flipped v. All right, so what conjunction means? Okay, so conjunction means to add, to add or to just like what we can say, to conjunct. Okay, uh, just like when there are two statements given. All right, just understand with the example. First of all, that first statement is given, Ram is in. All right, and then second statement is given, he can climb the tree. Okay, so when we use, when now how it can be represented in one sentence using these two sentences. Okay, so it can be framed in one sentence like, Ram is in, and see, look at this word, and I will tell you its importance. And he can climb the tree. All right, so what we have used to connect these two sentences and frame one sentence, and we use what, which connective, and. So always remember, the conjunction is represented by dot or this flipped v, and in the English letter it is no, it will be represented as and. Okay, and means what? And means that this statement should be true and this second statement should be true to make this whole statement true. All right, so to give the output of the whole statement as true, both the statement must be true. Okay, this is must condition. All right, so now we will perform the I will show you how you can plot the truth values. See, I told you what are truth values, that uh, values are the outcomes. Okay, so from the input. So whenever you give the input, then it will generate some, see, this is input and it will generate some output. Okay, whenever you give function, so this is the basic principle of function. So these are also functions. Okay, see, variables perform some action, so these are they are functions. All right, I think you got the logic. So let me tell you. Okay, so whenever there are two variables, just like we say a, and we consider this a as the first statement, b as the second statement. All right, so how many values there can be? So in the C, now you will get why I was teaching the number systems in the beginning. Okay, okay, just wait and check this. Okay, sorry for the glitch. Okay, so when we have two values, all right, so what can be the truth values? Okay, so let me just form table for you. I can do with this. I think I should do it. Okay, so what can be the truth values? All right, so either see 0 represent what in binary values? It represents false. Always remember 0 represent false, 1 represent true. I told you that in the binary number system lecture. So if you don't know, then you can watch that lecture and then you can resume. Okay, so 0 represent false and 1 represent true. So in the input part, okay, see this represent input. Okay, let me draw it more. So sorry for that. All right. So this one, see, we have given A input, we have given B input, and then we have to generate output. And output of this is what? If we generate AND operation. So when we use A variable and B variable, all right, then it will generate this A dot B or this conjunction. Okay, this is for conjunction. Its output will be A dot B and A B. All right, so now what we will write, we will use the simplest convention, that is dot one. All right, dot and plus, but always remember that you have to you having this also. Okay, let me tell you a trick to remember, but after completing the next part. Okay, I will tell you the trick, because after understanding next part, then only you can you will grab what is the trick and how it works. Okay, so now is what this is what our truth table. These are the variables. Okay, now we have to these this is what these two columns, these two columns are known as, and this column is known as output. All right, so in the input part, in the input part, suppose what values we can give, either it can be true or it can be false. So first consider that it is false and this also false. All right, so and in the second condition, just think about that we have one this part false and this part true, and in the second condition this part true, this part false, and this part in the last condition we have both the part true. So think, see, just take this like multiplication, use the rules of multiplication. What can be the output when you multiply this with this? See, because in and both the conditions must be true. So if any one disagrees, then whole disagrees. Okay, because it is compulsory to, to have the agreement of both the statements. So think, when any one disagrees, then the whole statement can be disagrees. Just let me explain you with a real world example. Okay, you go to a shopkeeper. All right, you are this person, this little guy. All right, you go to the shopkeeper. Okay, shop, and shopkeeper tells you the price 500. but you have 300 rupees with you. So you start bargaining with the shopkeeper. Shopkeeper told that I will give you for 400. You asked, no, please give it me for 300. But think what can be the values. Okay, so when shopkeeper is agree that sorry, let me explain it first. See, when shopkeeper wants to give you for 500 and you have 300, so you both are disagreed. Okay, this and disagreed with each other. So this can be what, zero zero values. Then what can be the conditions that shopkeeper reduces the price. Okay, he said 400. All right, said 400. So when it get 400, when he said 400, then he agrees to pay, give you for 400. So and but you disagrees. So this can be the condition. Then what can be the condition? All right. Now what can be the condition that you shopkeeper again reduces the price, but you don't know what is the price, but you agrees to buy this one. All right, but shopkeeper don't have more to give you on that price. Okay, then you both come to a conclusion that it must be bought for 300, and then this condition. All right, I think you have understood, or if you don't, then please comment down in the comment section. I will again explain it to you. Okay, all right. So now see, then multiply this two, then you get zero, then you get one. Sorry, zero, and then zero, and this one. Why? Both are disagreeing. So output will be disagree. And one is agree and one is disagree. So see what has happened. If shopkeeper is agree and the buyer is disagree, then transaction will not happen. So so for not happening, the value is zero. Then when shopkeeper agrees but the buyer is not agree, then the output will be zero. That is disagreement. When both agrees, then transaction will happen and values will go to 1. That's why we are using the multiplication, because using multiplication, when both the values are 1, then we get the value true. Okay, so in conjunction you can write then that when when both values are true, then output is true. All right, so then we get now I think you have understood the concept of conjunction. But now what can be the value? Okay, see, we can perform the disjunction also. What is disjunction? Second, disjunction. Disjunction means any one agree, then transaction will happen. All right, so anyone is agree, then transaction will happen. So it is represented by what? It is represented by plus operator and by this. All right, and in the English language word we use or. Or means what? uh, Either this or this. That means either sentence 1 is agree, or the person, sorry, sentence 2 is agree. So when either of them is agrees, then the transaction will happen. All right, so if I if I tell you to make a truth table, I think you can draw, but I am telling you, I will give you the truth table as your assignments for the other statements. All right, so when we have two values, these are input, These are input, and we have to perform some action and output. This is output, and what can be represented as a plus. All right. So now, what can be the values? All right. When you use two variables, see, always remember that it is the number of values. Okay. So the number of values are 2's power n, and n is what? Number of these variables. Okay. So input values depends on this value. Input values, number of input values, number of input values depends on this. So for two variables, it is 2 power 2, that is 4, and here also it is 2 power 2, that is 4. So we have four values. All right. If we have given a, b, and c variable, then how many values it can contain? 2 power 3, that is 8 input values. So we have to increase the number of columns, and we have to make 8 columns, but here we are making 4 columns. All right. Now input the values. One more trick I should tell you. Two tricks. So first trick is what? So when you are getting four input values, so in binary number system, we can convert into arithmetic number system. So what can be the values? It can be 0, 1, 2, and 3. All right. So right here 0, 1, 2, and 3, and try see, take these a and b as 2 bits. All right, 2 bits. Now form these 0, 1, 2, and 3 with these 2 bits. Okay, so when you have to perform 0, 0, then you have to put these bits 0. Then when you have to get 1, then you have to make it like this. Then when you have to get to what next to, then its binary number is this. When you have to get 3, then its binary number is this. So in that way also you can make these values. I am telling you this because in the further section we will be having some more complex truth tables. That's why you should remember this. All right. So this is 0, 1, 1, 0, and 1, 1. Now perform A or B. C, use OR. All right. If either of these is true, then the output will be true. So these both are false. So no one agrees. That means it is disagreement. Then now what happens? A is agree, but A don't agree, but B agree. Then it can be possible that in the transaction should happen. A agrees, B disagrees, then also possibility. When both are agrees, then it is common sense that transaction will always happen. Okay, so this is concept of the disjunction. Now second trick is what? See, the conjunction you are seeing like this, and in the disjunction you are seeing like this. Okay, so which has more number of ones? I think disjunction has more number of ones. So think its shape. If you pour something in this cup, so it will contain in this. All right. So whenever you get some more values, just like take example of this, you are getting more number of true values. So in case of conjunction, just think like that it is cup, and it can accommodate more number of true values, and in false it can accommodate at the top only, that is one true value, and all the all the true values will fall down apart from it. Okay, so I think you have got the trick. Now what is next? What is next is negation. All right, this is third connective, negation. What is negation? Negation means if I say that A is ready, then output will be A is not ready. Okay, its representation is what? Either you use this symbol or you use this symbol, just like this and this. it has only one variable, that is you will get understood by truth table easily. So when I construct truth table, see, we have only one input, eh, and depend on this value. If this value is uh, false and this value is true, okay, so when you get this value, then it's output, this op output, and this is input. So when you have the false value, then it will return the true value. When you have the true value, then it will return the false value. This is very simple. All right. So when I say that I will go, then my meaning of saying is that I will not. All right. I think you have understood. Then we have what? Double negation. Fourth one is double negation. See, think about the previous one. Okay, let me just draw here a dash. Okay, so what is this? If a agrees, then output will be a sorry disagrees, then output will be agreement, and when a agrees, then output will be disagreement. Okay, again we take, if we take this again as input to another negation, that is double negation. So what we can get, if the output of the previous one is true, then it will false, and when this is true, this is false, then it will be true. So what double negation means? Double negation means negating a negative component. Okay, so it will give what? It will give the original component. See, as you can see from this these values is always sorry, let's draw it like a. This is a. All right, this is what double negation. Then what comes? It comes implication and condition. So implication and conditional. Fifth one is implication. In implication, or we can say that it is conditional. So in the above parts, we use what? We use and, or, and not. Okay, but here we will using if there is some statement, then means we will be concluding on the basis of some condition. Okay, so this output will be depends on this condition. That means output and input and output will be on the same in same sentence. Okay, just for example, if I say if a, then b. All right, it means what? If a is true, then only b will be true. All right, if a is false, then b will also be false. A is true, then b will also be true. Okay, and it can be represented by the equation. Okay, just remember this equation. It is and first of all, its representation is this one, only this one. All right, so how we can write the simple form and write it as. So if we want to see, this is derived one, and it is derived from the above three propositional logics. Okay, so when we get to the, see, those were the three principal connectives, that is and, or, and not, that is conjunction, disjunction, and negation. So if we try to write it like in the form of the, and then what we will be getting, a negation or b, that is a negation plus b. All right, so I think you can find the truth table of this easily. I'm telling you, and for the next one I will give you an assignment. All right, so you are given what? This is a input, this is b input. How many number of variables? Two. So total number of inputs 4. So this is what A, this is what B, and then calculate A dash separately, and calculate, then calculate A dash B. All right. So what this A dash will represent, this. All right, that is our output. So this will be the output. So this will be the input, and this is part to generate output. So it is intermediate. Okay, so what are the values? I told you how to form these values. So if you don't, then you can watch from this part also. Please rewind the video and watch. Okay, so we will be getting, let me change the pen. All right, so 0 0 0 1 1 0, this is what 1 1. So what a dash will represent opposite of a, that is 1 1, and 0 0. So now we have to disjunct these two values, means either of them true, then output will be true. So 0 1, it will give 1, 1 1, it's understood that it will always give 1, 0 0, that it means it will generate false, this 1 0, it will 1. All right, so this is the truth table for the implication. Okay, that is conditional. Now what, let me give you a real world sentence example. Okay, example. So if it is holiday, it is holiday, so what, if it is holiday, then what, then I will go for a movie. See, going to movie, going to movie, this depends on what, this holiday. So B is depends upon A. That is, if A will be happening, then B will happen. If A will not happen, then B will not. All right. I think you have got the concept. Now we have got the equivalence. Sixth one is equivalence. What is this equivalence? See, simply, I think without going into deep, just remember its formula, because its use is up to the formula. Okay, and its representation. So it is represented by this. This. It is also known as what? It is also known as biconditional. This is biconditional. That means it is not only B is not only depends on A, but also A also depends on B. Okay, and its formula is A. B. It gives A dash B dash, that is A conjunction B conjunction, then plus A, sorry, this is conjunction, yes, conjunction, and this is disjunction. Okay, A dot sorry, A dot. So this is your assignment. This is your assignment to form its truth table. Truth table. All right. Same procedure which I have followed here and the previous ones, and always remember this concept, this logic. You will never fail to build a logic. All right. So now then, what is the next topic that we are going to learn? Okay. See, next we have to learn about antecedent and consequent. Antecedent and consequent. All right, antecedents and consequence. If we take this example, if A then B, then A can be termed as antecedent. That means it comes first, and B then B comes, and B depends on A, and B is known as consequent. Just remember this only thing. You will never fail. All right. Now there are some more logics, just like these 6 ones. There are some more, and there are 3 more logics. 3 more, and what are they? There are converse, inverse, and what? Contrapositive. All right. So now what? You know what is antecedent? Always for these three, remember this statement: A, station B, and what is this? Antecedent, and this is what? Consequence. All right. So for converse, if we have given this statement, this is what given. That is, if A then B. So when we interchange, converse means interchange of A and B. Interchange A and B. So what we will be getting? B implication A. That is, if B then A. All right, then it is known as conversing. Means conversing a statement. Okay. So when we apply converse operation, that is, this is given A implication, A implication B, and we perform what? Converse, and it will give B implication A. And you know the meaning of this. This means that if A is true, then B is true, and if A is false, then B is false. Similarly, when we apply conversion, then it will be, if B is true, then A will be, and if B is false, then A is false. Okay. So this is what converse. Now inverse. Now second one is inverse. All right, second one is inverse. So in the inverse condition, what we will be performing? See, you will get from this only what I am trying to say. A is B, and we perform inverse. Then what we will get? A dash B, which means what? Let me give you example. Listen to me. All right. So consider statement: if it rains, then the sky is cloudy. If it rains, then the sky is cloudy. Then its inverse will be, if it is not rain, if it does not rain, then the sky is clear. All right. So the second condition is, sorry, here I have got some error. Yes, it can be represented by this, but always remember that the first is statement. This is statement 1, and this is statement 2. So this can be the negation of, this must be negation. Actually, here it whole comes negation. First one is the negation of second one. Then it is known as inverse. All right. Then we come to contrapositive. Contrapositive. In the contrapositive condition is what? Okay. So just think like, when in this condition we are converting like this. Okay. Then we are given this: if A and we apply contra positive. So when we apply this, then it will become like this. First we will perform the what? Perform the converse operation. Okay, then we will negate it. Then it is known as contrapositive. All right. This means what? If it rains, then the sky is cloudy. If I say if it rains, then the sky is cloudy. Then what will be the output? Okay, that if it does, if the sky is cloudy, if the sky is not cloudy, then it rains. Okay. And second example, I can take that. First one is you play, and the second one is that is A's value is you play, and the value of B is you will not go to a party. So what its contrapositive will be? If you will go to a party, then you do not play. I think you have understood. Now the main thing, the main whole stuff is going to be from now on. Okay, so you have to understand these terms very seriously to get the concept of the upcoming topics. All right, what are these? These are three things. That is, first is tautology, is one term. Then contradiction, and the third one is contingency. All right. So what these terms mean? First, we will discuss about tautology. So tautology, you can check the spelling on the internet because I am teaching you the board. So please pardon. Okay. When if we apply any value, okay, we apply an either one that is either zero that is false or the one that is true, then it will always give the output as true. Okay. How it can be done so? So suppose taking the truth table, we have one value. Okay. So if we add one, okay, we if we conjunct one, all right. So what is that values for a? The values for a will be single value, then 0 and 1. And values for 1, it always be 1. So when we perform a plus 1, that is a disjunction 1, then it will give always 1. Always 1. So the outputs are 1. That is outputs are true. So when the all outputs are true, then it is known as tautology. Okay. If I explain it to you with another example, then just take this. But I am making the truth table a dot b dash and what a dot b plus a dot. Now it's your responsibility and it's your assignment to perform to make the truth table, complete this truth table, complete, and check whether it is tautology or not. When tautology is when this, see, this is output, this is input, and these are intermediate. All right. So tautology is when all the output are one or true is known as tautology. All right. So perform the truth table with your own and conclude whether it is tautology or not. And what we will come? It comes contradiction. Contra. This is your assignment. All right. This is your assignment question. This is assignment. This is second question. What was first question? I think you have noted it down. Assignment. Yes, this is first assignment. Just please solve all these two. All right. And contradiction. Contradiction is just opposite of opposite of tautology. So how, if tautology is made by adding one if a single variable, and if it is made by just adding one or disjuncting one, so how tautology can be, how contradiction will be. So contradiction can be found by conjuncting, that is dot one, performing dot operation one with the very, sorry, dot zero. All right. So for example, if I get a, so if I get values for a is zeros and one. All right. If I conjunct, that is if I conjunct zeros to them, so what can be the what will be the output? It will be, so all the outputs are zeros, then it is known as contradiction. Now I am giving you third assignment question. Third question is what? You have given a and b values. All right, a and b values. You have to perform a dot b, a b, a dash b as intermediary. These are intermediary. This is input, and this is what? A dot b dot a dash as op, output. This is output. What output? Have to generate the output of this. These are some values. This can dot as this dot a dash, and then perform the operations and conclude that whether it is contradiction or not. Contradiction or not. All right. Then what we will be getting? We will be getting contingency. What is our third topic to learn? Contingency. What is contingency? When we get final result that contains both ones and zero, then it is known as contingent. See, all the truth table we have performed here contains both the values. Also contains both. It also contains both the output of these two tables. So all these were the contingency. All right. Have you understood? When the output consists of both 0 and 1, then it is known as contingency. So assignment 4, question number 4, as your assignment, draw the truth table for these values, a plus b, and output will be a dot a plus b. This is output, this is intermediary, this is input, and conclude that whether it is contingency or not. All right. Now okay, so now what is the next topic? And next topic is syllogism. Syllogism. So what is syllogism? So syllogism is process of drawing conclusion. Okay. This is simple process. Syllogism means process. It is the term. Actually, syllogism is a term. So how we can draw conclusion? We can draw conclusion by using these two methods, by using truth tables, or second by using algebraic laws. See, we have generated the truth tables here to generate the what, to conclude, generate the conclusion. What is the conclusion of conjunction? What is disjunction? What is negation? So that method was the truth table value. Okay, and sometimes we write these expressions. So what is this? This is algebraic laws. So there are some algebraic laws we will be discussing in the next video. For this video, I think I should conclude here only. But I have given 4 assignment questions. So now I let me give you some more questions also. Okay. So your that is I have given already given 4. Then your fifth question is draw the truth table for this this output. Draw truth table for this output. I think you know how to make a truth table. For example, let me explain you the procedure. But you have to fill the entries. So first of all, see how many distinct variables are there. There are 3 distinct variables, that is A, B, and C. So how many inputs will be? Choose part 3, that is 8. So instead of making 4 entries, you have to make 8 entries. What of what values? 0, 1, 3, 4, 5, 6, and 7. And how you have to consider this A, B, and C. This is first bit, this is second bit, this is third bit. Now what you in these 3, how you can write 0? You can write 0 as this one. How you can write 3? You can write 3 as 0 1 1. How you can write 6? You can write 6 as this. All right. So like this you have to fill the values. Then perform the intermediaries, that is this is first intermediary, this second intermediary, and if you want to make more intermediaries to calculate these also, then you can make it. All right. Then final output, that is output statement, and on this, that is A, B, C, what. All right, I think you have got the question. Okay, so fifth question is this. Then for the sixth question, perform. See, now perform the prove. You have to prove. What is proof? That these two statements are equivalent. So how you can check? Let me first explain and tell you the question. So what is the question? X Z. All right, equals to this, this, and this, this, and this, and so how you can, let me tell you the procedure. All right, so how you can prove that these two are equal? So find the truth table for this. Truth table 1 you have to draw. Initially you draw truth table separately, and then draw truth table for this. It will be table 2. Okay, it will be table 2. Then this will be the output of first truth table, this will be the output of second truth table. Then check all the output values are equal or not. If they are equal, then they are equal, and if not, then they are. All right, I think you have got the procedure. See, for now these 6 questions are enough. All right, so please solve it. Thank you all for today. We will meet in the next lecture. Thank you.